So in this video, we're going to look at two different ways of finding vectors when we're given a magnitude and a direction. So the first possibility is I can be given the magnitude or length that I want the vector to be. So in this case, it says find a vector of length pi that makes an angle of 5 pi over 6 with the positive x-axis. So I'm being given the length of the vector directly, and I'm being given the angle that the vector makes with the positive x-axis. And to do this one, we just need to remember our trigonometry. What we want to remember is that when we were working on the unit circle, any point on the unit circle, if we know the angle that the line segment from the origin to that point makes with the positive x-axis, so if we call this angle theta, the angle that this line segment makes with the positive x-axis on the unit circle whose radius is 1, we know that the ordered pair on the unit circle is cosine theta sine theta. So this was a key result early on in trigonometry. So that means that the vector from the origin to this point, if I make the origin the initial point and this point on the unit circle a terminal point, this vector is just going to be drop the point notation and put the vector notation on it. And here I have a vector of length 1. The magnitude of this vector is length 1. And the idea is if I want any other length, if I want some length, say r, so r is just a positive scalar. If I want a length r, I just scale this vector of length 1 out into this position. So again, from trigonometry, if this distance from the origin to this point is a distance of r, then right here, this point would be r cosine theta, r sine theta, which means the vector to that point is going to be the vector r cosine theta, r sine theta. So in the particular example that we have here, we want a vector of length pi, and we want it to make an angle of 5 pi over 6 with the positive x-axis. So 5 pi over 6 is going to be about here. Here's the angle 5 pi over 6. And we know that the ordered pair right here on the unit circle is given by cosine of 5 pi over 6, comma, sine of 5 pi over 6. And if that's the ordered pair there, then the vector there is just the vector cosine of 5 pi over 6, sine of 5 pi over 6. And it's a vector of length 1 because it's on the unit circle where the radius is 1. So if I want a vector of length pi, I just stretch this vector by a scalar of pi. I multiply pi times the vector of length 1. Remember, the length of a scalar times a vector will be the length of the scalar, absolute value of the scalar times the length of the vector. So this will have length pi, because it'll be pi times 1 is pi distance units long. So we just put in our cosine of 5 pi over 6, comma, our sine of 5 pi over 6. And if I wanted an exact answer and this wasn't a special angle, I could stop here. I do have a special angle, so I could simplify this. The cosine of 5 pi over 6 is negative square root of 3 over 2, and the sine of 5 pi over 6 is positive 1/2. And now I have a vector of length pi in the direction of 5 pi over 6, and I could choose to distribute the pi into that vector or not. That would depend on what I wanted. It would depend more on the practical application I was working on and whether it was convenient to keep it in a factored form or not. The other way the directional information can be given to you is it can just be given to you as a vector. Hey, find a vector of length 7 in the direction of 3, 3. And I actually wanted that to be 3, 4, so it came out nicely. The vector 3, 3 just makes an angle of 45 degrees with the positive x-axis, so that's a little bit boring. I wanted a Pythagorean triple. I had a typo there, and I just fixed it. So vector of length 7 in the direction of the vector 3, 4. So the idea is, hey, you've got this vector over 3, up 4. Maybe he looks something like this. and you want a vector that points in the same direction, but that has length 7, and this vector doesn't have length 7. In fact, if we give this vector a name, call him u, then we know to calculate the size of u, we take the square root of the sum of the squares of the vector components, and this is going to be 9 plus it's going to be 9 plus 16 is 25. The square root of 25 is going to be 5. So this vector here has length 5, not length 7. And the idea is you want to construct u hat. So remember, u hat is the vector of length 1 in the same direction. So to make u hat, if you recall from the previous video, we take 1/5 of the vector u, and we shrink vector u down so that he is not the same size anymore. So if we, hey, where'd my, there it is. No, it's not what I wanted. I want to change my pen color. Pointer options, ink color. Come on. Oh my word. Okay, I'm going to try one more time before I get, oh, maybe I'll just make it big. No, that's not big. Come on. Pointer options, be smooth. Be smooth. Ink color, black. Black. Come on. Haha. Okay, so if you do 1/5 of u to make u hat, you shrink the vector of length 5 down so that it's a vector of length 1. And now you have a vector of length 1 that's pointing in the direction that you're interested in. And then what you can do to get the vector that you want, we'll call him w, to get the vector of length 7 in the direction of u, we just take 7 times u hat, who is a vector of length 1, which now gives you a vector whose length is 7. Size is 7, size is 1, 7 times 1 is 7. So we wind up doing 7 times 1/5 of the vector u, because u hat is 1/5 of u. So the vector whose length is 7, who points in the direction of u, is going to be the vector 7/5 times the vector 3/4. So again, the process is, if I want a vector of a particular length in the direction of a given vector, find the length of the vector, divide the vector you have by the length of the vector, which is the same as multiplying by the reciprocal of the vector length, so 1/5 of u to get u hat, a vector of length 1, and then take that vector of length 1 and scale it to the length that you want. This will take that, the 1/5 u shrunk us down so that we got u hat right here, and now 7 times u hat is going to stretch him out to the appropriate length.